I'm going to speak about a new topic in 9.4 called logical decoding and replication. So, a couple of words about myself. I am Paquier. You can pronounce my name as Michael as you want. I'm working on Postgres for a company that you may know called VMware. And I'm actually only doing PostgreSQL work. You may know me also as a community hacker. I sometimes go to the mailing list, complain or send patches, review patches. And I have also a community blog that you may have seen in the past. I try to cover the new features when they come inside the code and try to, to come in, review what they do, and to let people know what Postgres has in its new things. So here's my blog and some contact information. If you have things about Postgres, like here are my email addresses. Today I'm going to talk to you about logical decoding, that's for sure. And here we go, introduction to logical decoding. Before coming to it, you have to be aware that this presentation is very hacker-oriented. So if you are a user of Postgres, you may be lost at some point. But I also try to focus on the use cases of this one by presenting a couple of things that you can do with the infrastructure that is already present in 9.4. Before coming to that, a couple of things you may need to know, because I'm going to reference to a couple of those words in the presentation. PostgreSQL uses as an internal structure to maintain data consistency, something called WAL, write ahead log, used for recovery archives, and anything like that. I think also I'm going to refer to something called the LSN. The LSN is a WAL, is a position inside the WAL journal itself. And there is also some documentation. If you want to refer to that during the presentation, you are free to do so. I'm also going to talk a little bit about WAL sender and WAL receiver, which are processes on the server and client side to send and receive WAL, something that is widely used, for example, for streaming replication itself. And also, of course, I'm going to talk about what is called the Replication Protocol. Magnus, who is in this room, has made a couple of presentations about the Replication Protocol itself. It has been extended in 9.4 for the need of logical decoding, and so you can refer to some portion of the documentation about that at some point. So, what is logical decoding? Logical decoding is a new plugin infrastructure that has been added in 9.4 that is the result of hundreds of emails and a result of huge patches that have been put inside core. It has introduced many sub-features and concepts that you may even use, or you could even use, without any need of logical decoding itself. The plugin infrastructure is really designed to be customizable, extensible, also you can adapt it to your own needs without modifying in any way the core code. And it can be used in a couple of use cases that I'm also going to cover a little bit in this presentation. So about the concept of logical decoding, the idea is that the PostgreSQL server itself writes WAL for each change that needs to be recorded in case a crash happens. And you need to recover from a given last checkpoint or a given last consistent point inside your data. So the point of logical decoding is to read basically this WAL and to decode the changes that occurred inside it when a DML has been issued inside the server. So when, for example, you have an insert, delete, and update, what roughly happens is that you record which data has been modified inside the code. If I recall correctly, it's hep.am.c. You can have a look at that. And so what this does is putting the WAL raw data into a shape that you can use to reshape the changes in the way you want. So you have two things to consider here. The first one is a part which is on the server side, which takes the wall, reads it, and puts it in a shape that your plugin that you have on the server side can use. And then you have also a second thing to consider, which is a receiver that would actually get back the changes that your decoder has reshaped in the way it wanted. So logical decoding and 9.4 have introduced many new sub-features, as I mentioned before. The first one, and perhaps something that you may even use without anything about logical decoding, is called a replication slot. Replication slots adds a new property on the server side, which is to allow the possibility to retain WAL files as long as the changes inside those WAL files are not consumed by a given receiver. A replication slot can be used only by one process at the same time. It's written WAL sender, but it's not actually exactly the case. And so when you get changes from one replication slot and the slot is still considered as active, you cannot use it for something else. Also, you need to be very careful about that. In 9.3 and even older servers, like the maximum number of WAL files that was retained on the server side was more or less decided by checkpoint segments and checkpoint timeout, which is, I think, you have a soft limit being the maximum of 3 checkpoint segments plus 1. When you use replication slots, you may retain even more WAL files because of that. And what's actually very useful for that is that, for example, even if you have standby that is connected to a given replication slot, you can let the standby can be disconnected for a long time, and it will be able to get back the WAL files that it needs without the need to, for example, customize parameters of the type WAL keep segments or things like that. So something to be very careful about that is that as it retains WAL, if you have a standby that consumes the changes from this replication slot, you need to be careful that your standby is not offline for a too long time, because you may blow up your pgxlog partition, for example. So you have two types of physical slots. I mentioned before that a standby can use it. A standby can use a slot for streaming replication itself, and in this case, the slot is called a physical slot, which is system-wide, and actually it can be used for conflict resolution to be able to maintain the transaction xmin horizon when the standby sends feedback to the master. Did I lose the audience here? No? Yep.
Are the changes sent to the receiver before the commit happens, or only after?
After the commit has happened. So you need to wait for the commit for the change to be materialized in this case.
So what happens on a transaction that spans more than a certain number of checkpoint segments?
I'm going to that at some point. But yes, that's something you need to be careful about. Standbys in 9.4 can use replication slots. You can specify inside your recovery.conf a new parameter called primary slot name, and the standby will use the changes from this replication slots. And using that, you will be able to retain as many WAL as you need for the recovery without the need to have, for example, your standby going back to the archives to fetch back files it may have missed on the master side. Or even another standby if it's a cascading standby, for example. Because I think you can also use replication slots on standby side. Never tested both. You can create replication slots using a given SQL interface. Like there is a dedicated function for that called pzcreate physical replication slots. And also you can use the replication protocol through a replication connection using the new command called create replication slot, physical in this case. On the PostgreSQL.conf side, you need to specify a parameter called max replication slots, which is used actually to initialize some shared memory structure, if I recall correctly, when the server starts up. So if you change this parameter, you also need to restart your server in this case. You can drop replication slots the same way as long as they are not active using an SQL interface or even similarly the replication protocol. Now, the fun part about replication slots is that you have a second type of replication slots dedicated to the logical decoding itself, called a logical replication slot. This one is not system-wide, but it is attached to one database. And it actually needs a decoder plugin on the server side to be able to reshape the changes that happened for this database when they are requested by a receiver. Logical replication slot cannot be used for recovery and streaming replication, for example, because it's only for one database. And similarly to the physical slots, you can create it using an SQL interface or even a new command called create replication slot through the replication protocol, which has an option called logical in this case. And you can see that also you need to specify the plugin name, which would be in this case the plugin in charge of reshaping the changes that happened inside the while. So you can see, for example, just down here that you can create a replication slot, and it returns back also an xlog position, which is in the case of the logical, while the LSN position, the log sequence number position, where the logs or the while are being retained. On the configuration side, you need max replication slots plus a new to set up one level to a new level that has been introduced in 9.4 called logical. So you need to set up a little bit more your server before using logical replication slots as well. Something also to be like, this is not new in 9.4, but that's something that's also important to consider for logical slots, which is exported snapshots. Exported snapshots have been added in 9.2, if I recall correctly. And actually, when you create a replication slot, you are able to get back an exported snapshot that you can afterwards use to retrieve a consistent image of your database when the slot was created. If you follow me. So you create a slot, you have a snapshot, and you can get an image of your database that you can use as a base before replaying records in this way. So you can actually get an exported snapshot when you create replication slots through a replication connection, and this snapshot is available for the duration of the replication connection. So once you disconnect the connection that created the replication slot, your snapshot is gone and you are not able anymore to take a consistent image of your database using that, which is actually, I think, using a set transaction snapshot, and then you set up the snapshot name. You can also export snapshots using an SQL interface, which is PG export snapshot. That's used, for example, by the parallel PG dump to ensure that the data that you get through the different connections is consistent in this case. You can also deactivate it if you want, but that's actually not something to consider on a live server when taking a dump. The important part is that if you use the SQL function to create a replication slot called pgcreate logical replication slot, you don't get back an exported snapshot. So that's something I'm going back to soon, but it's something that is important to mention, I think. Of course, when you use an exported snapshot, you need to be sure that, for example, in the case of the SQL interface, the snapshot is only alive for the duration of the transaction that took it. And for the replication connection, as long as the replication connection is live. So the life duration of an exported snapshot is limited. So you can use it to dump consistent data, and actually you need to dump your data inside a single transaction using the command called set transaction snapshot that needs to be the first command launched in a transaction, if I recall correctly. For the time being, when you create a replication slot, as you need to have a snapshot name, the tricky part is that you need to have a replication connection alive for the duration of the time where you want to take the consistent snapshot of your data, like when you want to take a dump of your data. Something also to notice is that it would be very user-friendly, for example, to be possible to use pgdump with a given snapshot name. This has been already discussed, but that's actually a little bit dangerous from the user, from the system point of view, because snapshots are not aware of schema changes. So one potential solution that I'm actually working on for 9.5 is to have pgdump create replication slots, and to use these replication slots inside pgdump that has created it to take dump of the data for a given database. If you see the point we are going to is that using that you would be able to create a slot that you could use as a base for other purposes using a facility that is already well used, like pgdump. That's something I'm going to work on for 9.5, hopefully in the next commit phase. So now if you want, with the 9.4 existing facilities, if you want to take a consistent state of your data when you create a replication slot, you need to have something that is tightly linked to your application and to your own schema, for example, such as I want only to dump this data, because, or you can still patch pgdump in some way to do that, but core has nothing on this side. So about the output decoder itself, so it decodes WAL from a logical replication slot, and this plugin needs to be installed on the server side. You don't need actually to load it inside the server itself, and it's being used by the server and loaded by the server once you create the logical replication slot. This output decoder can be used in two circumstances and is activated only once the replication slot is marked as active, which is in the case of the replication protocol, a WAL sender itself, or when you query a given set of SQL functions to get back changes, reshaped changes from a decoder, it gets activated when you call those functions. An important thing to notice, and something that Bruce just questioned about something like 10 minutes ago, is that you have one change by tuple modified. So for example, if you do a bulk copy on your application that adds 1 million rows, you will have one change per row that has been done. So for example, a simple insert into a table using generate series for 1,000 tuples would generate basically 1,000 changes there. So this is good for OLTP kind of application and short transactions. But the best thing you could do is for warehouse type of applications, is to create a new slot to dump your data from it and to apply changes one by one as long as you are sure that the footprint that your database delta changes are minimum on this side to maximize the performance. PostgreSQL comes up with a decoder itself called test decoding, and that's actually a good thing to start up with. Decoder can also use custom options, so you can, if you have implemented that inside your decoder, use some custom output format on the fly using some custom options inside that. Something else that is being used is that, for example, you have changes that are fetched back from the wall, but you need also, at some point, a reference for a given relation to be able to identify the rows that have been modified uniquely. And that's where a new feature called Replica Identity comes in. Replica Identity provides some change information verbosity of old rows being updated or deleted, depending on the mode it is being using. And in 9.4, this replica identity thing is using with 4 modes. The default one is, for example, if you have a relation that uses a primary key, when you update or delete a row, you can get back the old information, the primary key information, such as you are able to identify uniquely the row that has been updated or deleted. Default comes up this way, and then you have several different verbosity modes. One using index that needs to be unique, not partial, no expression, so it's more or less a kind of primary key. And it provides the same verbosity actually as a default with a primary key. You have also something that has all, so you are able to use all the old column information to identify your tuple, and nothing, which is, in this case, you just don't identify at all the old rows. And that's the same as the default case when the relation has no primary key. At the SQL level, you can change this verbosity when you use alter table. And the default using create table is default itself. So you need to do a create table and an alter table for that, to change the verbosity of a given relation. And then about the logical change receiver part. So I talked about the thing on the server side, which is the decoder. Now you need something that fetches the changes and is able to apply them in what you want to do. So basically, you are free to do a lot of things on this side. The important thing to consider is that your receiver will run somewhere on another source on a client side, and can be something that is able to use the replication protocol, for example, to fetch back the logical changes. So it's something that basically it can be a lot of things, something that is able to fetch changes and apply them, process them, or even do some extra processing as freely as you want. And the important part is that this receiver can use the options embedded inside the decoder itself to customize the output in the way you want. So you have a couple of things you can use for that. The first one is like inside 9.4 there is an SQL interface that allows you to get back changes from a given replication slot. So you have a set of get and pick functions to consume the changes or even look at them before they are being generated. You need to be aware that one single change inside one single WAR record generates basically one change per tuple modified, updated, deleted, or inserted. So for example, if you use the get or pick change on one change that has thousands of modifications inside its tuples, like thousands of tuple modifications, the processing inside the server for a single get or pick can take a little bit of time. There is also something inside the replication protocol using a couple of APIs inside LPQ for copy. And that's somewhat helpful as well. So yes, replication. So when you connect using clients through a replication connection, you can do a couple of things. And for example, when you have your own standby and you connect it to a master, you can, for example, identify your standby using inside the connection string in recovery.conf. You can use a parameter called application name that will allow you to identify this standby in the, for example, pgstat replication view. And you can do the same for a logical receiver because it uses replication connection. So you are able to identify at the same level as vanilla standby your own logical receiver in this case. And it can also use the same queries as standby itself. But that's very verbose. Like you need to have some knowledge of that if you want to use that properly. So you can use the given queries like identify system to identify the system a given receiver is connected to. You can create slots, drop slots, and also you can use a command called start replication slots that allows you to begin fetching changes from a given replication slot, those changes being the ones that your decoder has created itself. When you start a replication slot, you can specify a start position. Actually, you have to specify a start position. And you can usually use here only 0-0, which is in this case the oldest X while position available in the slot. Like you can rely on the default in this case. So for the logical decoding replication, when you have a receiver and you use a replication connection to connect to the master server, use the application name to be able to identify it. But now the fun part is that using this application name, you can somewhat fake the master server to let it believe that what is connected to it is synchronous standby itself. So for example, what you could do is that you have your own custom logical receiver, and what you can do using, for example, standby synchronous names is let the master think that this is a synchronous standby, and that you need for your client to flush or to write on the remote side what has been added. The important point here is that you need, in this case, to send feedback to the master node about what has been applied on the client side, which is basically what vanilla standby nodes do. And that's actually something you absolutely need to do, because if you don't do that, the master node will not release WAL files, and so it would retain indefinitely all the changes that happened on the node side. So you can use for that things like flush position and write position to report back from your client to the server and to release WAL files that happen on the master. And this actually brings you a lot of control under what a logical receiver can do. You can make it believe like an asynchronous node, a synchronous node, and it's really up to you. Making this logical decoding facility a very powerful thing. So before going to the next parts, like it's Friday night, I can understand. So you guys might be a little bit lost. If you have any questions. Yeah?
Does that also apply to synchronous commit?
Yes, actually I was mentioning the synchronous commit, because synchronous commit can be set to, if I recall correctly, to on, off, remote write and local. And actually for the remote write, what you wait for is the write position that has been reported back by the client to the server side. If it's on, you wait for the flush position. And actually, depending on this parameter value, you check for either the write position or the flush position to say this node is synchronous and has satisfied the synchronous commit thing. So just to be sure here, because that's really hacker stuff from now. Who has already developed one extension, use the libpq APIs in this room? No, you I know. Like, have you already developed extensions for Postgres? Okay. Yeah, that's fine. Like, so, like, I'm really trying to put with this presentation in your hands basic understanding on what this is, such as you would be able by yourself to begin developing decoder plugins, for example, for your customers, or I don't know, for your own needs and things like that. So On the server side, you have the output decoders, which is basically a set of callback functions. When you start decoder, when you shut down it, and when a set of events happen inside the while files being read, when the changes are being requested. Those changes are when a transaction begins, commits, or when a DML event has been triggered inside the while files, which may be something like an insertion, update, or delete. I have actually created, for the sake of this presentation, myself a plugin, decoder plugin. And this decoder plugin is able to take changes and to generate raw SQL queries from the changes that occurred. So, like, using your set of callbacks, you can set up easily the callbacks being done using a set of functions. Like for somebody who has seen my presentation of last year about background workers, the initialization is more or less similar to that. You just register a set of functions that you define by yourself and that the server will use to trigger events, to trigger those functions when given events happen on the server side, when reading the WAL files. So you have, for example, when you start up a decoder context, which is in this case when, for example, your replication slot becomes active and a receiver connects to it. You can start up a context in that to store, for example, custom options or create a given context of data that you may want to use for yourself. Well, that's used for initialization of the whole context of the decoder. In the way, for example, this is called exactly when you call the start replication command through the replication protocol. When, of course, you shut down the things, you need to clean up what you have done inside the initialization, basically consisting in deleting the memory context you may have created, or even deleting or cleaning up other things you did at initialization step. You have also, when a begin event happens, you have a set of data that is available to you, and you can use this set of data to create changes which are basically strings that you generate by yourself. For example, in the case of my own decoder, what I wanted was something that is able to generate raw queries. So when a begin event happens, what this stuff is basically doing is, as you can see here, like we create a begin string that generates a raw query, simply. In the same order of things, when you have a commit that happens, what you do simply is you generate a simple commit. You have a lot of extra information about that, like the while position of these commits, and you can save the changes as you want, or even generate multiple changes inside a single callback event itself. When you have, of course, DML changes, you have a single callback that is called, and you can go through your code and do what you want depending on the event that happened. For example, if you have an insert, update, and delete query, what you can do is generating the change you want depending on what happens. So for example, in the case of my decoder row, what I'm doing is checking the replica identity of a given relation to generate a where clause to be able to identify the table to update or delete itself. So I try to make this plugin as smart as possible. May have still some problems, but still, it's pretty smart. So now, if you have the motivation to do so, you can hack your own decoders, or even contribute back if you find any bugs in the current infrastructure, which is still possible. And what I would recommend is that if you begin hacking something, the best thing you can do is to begin by touching the contrib module called test decoding. That is really helpful when you want to begin something from scratch. It uses custom options, so what basically you could do is do copy-paste on this code and then modify it as you want, and you will minimize your risk of bugs inside your own decoder. So just to show you guys how this works, I'm going to set up a PostgreSQL server. Like, this is using my own scripts, but you need to believe me. So I have my server that is running, and actually this server is set up with the WAL level logical and also value of max replication slots that is higher than 1. Yes, we have 10. So what I am going to do is first, like, do that bigger first. And what I'm going to do is to create a replication slot. Like, I never recall this function name. So we have create logical replication slot that I'm just going to copy paste for the need of that. And I'm going to create a replication slot called foo that uses my custom plugin called Decoder row that is able to create row queries using the changes that happened. So this worked. This replication slot information is available in the system view called PG replication slots. So I have here for my plugin Decoder row a slot foo that is yet not active because I'm not being using it yet. And it's available on the database, which is the default here, the username of this machine. So now what you can do is we have a set of functions that allow us to have a look at the changes that happened inside a given replication slot. So I'm going to use the function called pglogical slot peak changes to have a look at the changes that happened since the replication slot has been created. So basically you would do something like call that, use the replication slot, and I'm also going to request only one change, explaining the one in this case. There is still nothing, because I have done actually nothing. But, for example, let's see, I'm going to create a table. Create table AA with only one single column. That is the primary key. As I mentioned before, replication slots are only able to grab changes from DML. So if we have a look at the changes that you can get from the replication slots, what we get is nothing. Okay, it's not working, sorry for that. I was testing today, but it's not working. So basically what was happening is that the decoder row plugin was creating a begin and a commit query, and those two changes are normally available, but that's not the case. By the way, let's create, oh, I think I know why. Yes. Actually, my plugin, I wrote my plugin some long time ago, but I have an option to choose if I generate the begin and commit queries. The default is not to generate them. That's why they are not here, I think. So if I, for example, insert into my table a value, what I'm able to see is, yes, like they're here. Like, I bypass the begin and the commit because I have also a custom option to generate them at will. So what this does is using the insert query that happened, I have one change that has been generated to generate a row query that could be perhaps applied somewhere else later on. So I have this insert into public AA with value something like that. What is also doable is, for example, you can update the relation. So let's update AA, set A equal 2, where A equal 1. So I updated that, and if I get once again the changes, I have an update query that can be used to update the relation AA that may be present somewhere else. And the plugin has been made, such as the workload generated using the primary key. That was available inside the relation. And if I recall correctly, for relations that have no primary keys or use the nothing replica identity thing, we do not generate updates and delete queries because we cannot select any tuples in this case. So here is an example of decoder plugin in this case. So for logical receivers, you can do a lot of things with that. And using, for example, the SQL interface available, you can use the set of get and pick functions, for example, to create what I try to create the simplest thing possible to be able to grab changes from a replication slot, which is in this case a simple bash script that runs in loop, sleeping and fetching one single change at a time from a given slot. So you could have that, and I think it's simply printing them in std out. So you can, for example, use that simply to get changes from a given replication slot. The advantage of the SQL interface is that it's light, it's simple. And also, when you use the SQL interface, you can, the changes are automatically consumed also on the server side. So while the changes fetched this way will make the while position incremented inside a given replication slot. So you don't need to return any feedback to the server in this case. So using the replication protocol, you can use the copy APIs to first open a connection, like you can do something like that, which is more or less what is available inside the country module PG, no, it's not a country module, it's PG receive logical in this case. And of course, you can fetch back changes using a copy API called pg-get copy data. So what you would get is for one single call of that, you would get a set of changes that you can then apply directly. So I think I don't have much time to cover that. You have the pg receive logical, which is in code that you can use to fetch changes directly. It can create and drop replication slots at will. And now I'm going to show you something that I hacked, because I have perhaps a little bit of time. Okay. So, sorry for that. And that did kill all on the stuff. So what I'm going to create now is a set of two nodes, two master nodes. One of these nodes has the decoder plugin inside it, and we have a second node that runs a background worker that receives dynamically those changes. So I'm actually creating a kind of asynchronous multi-master using that, without modifying the core code itself. So I have my set of two nodes. I'm going to connect to the first one, to the second one. As logical decoding does not replicate schema, what I have done was copying the schema between those two nodes. And in this case, what I did was creating my previous table AA, which has, I think, a primary key. It doesn't have a primary key, it doesn't matter. So I have those two nodes running here. And for example, if I do an insertion on the first node, what the second node is going to do, just to be sure that I'm not cheating, I'm showing you I'm connecting using PSQL -p and the node and the port number. For the second node, I'm just reconnecting just to show you, and I'm running a second node running on a different port. So what I'm basically going to do is inserting a simple tuple here on this node, and actually this change gets replicated on the second node automatically. And that's a master node, so you can still reinsert here, for example, more stuff. Like you wouldn't do it, but this node has been done to replicate stuff automatically. And it runs only a background worker that connects to the other node using the replication protocol. So the code of those things is available on GitHub. It's under the PostgreSQL license. So if you want to have a look, feel free. And actually, those modules could be used for solutions of the type online upgrade. Because what actually you could do is dump a schema on another node and use the module I just implemented to duplicate changes as long as, like, for example, you dump the data on your other node, you create a second one, you apply the dump on the other one, and during the time the dump was applied, you will have your replication slot that would get full with changes, so you reapply them and then you perform a switchover. And your online, in this case, the upgrade downtime would be only the switchover time between the two nodes. So the point is that for this kind of thing, I think that you need advanced hacking skills. You can do a lot of things. It took me a little bit of time to do things with that, and you cannot yet, for example, get consistent dumps using pgdumps. Using pgdump, but once I'm actually able to get consistent dumps creating a slot with pgdump and using the modules that I just presented to you, you have an online upgrade solution at hand. You can also use logical decoding, for example, for other things like replication solutions. Like I think Slowney is going to use that for its own needs. Also for audit purposes. You can do a lot of things, and you could, for example, even grab the changes and reapply them to another source, like, I don't know, like it's bad what I'm going to say, but if you have an Oracle database running, of course, nobody runs it here, but if you have an Oracle database, you could get the changes that you reshaped and apply them on another server. I don't know, it could be anything else. So thanks. If you have any questions. I know it's hard for a Friday night. Yes. Sorry, you asked once. So.
If you have a DML statement that updates multiple rows,
yeah.
On the other end, when you transfer it, it's going to come out as one statement per row, or are you able to?
Yeah, it's one statement per row. But actually, you could modify the plugin, such as when the first DML event happens, you just create the update set part. That actually, even for an update, that is kind of tricky because you need to have a good selectivity of things. But you could, for example, maintain the update part on a given place, like you maintain static pointer. You have the where part in another static pointer, and when the commit event happens, you just create a single change that generates the whole stuff. Like it's possible as well. Like I was lazy, perhaps, but I think for the purpose of this presentation, at least, it's enough. But yes, you can do that as well. You can create as well multiple changes as well, because like in my case, for one given event, I created one single thing, but you can create series of changes for it. For example, let's say you want the transaction ID, you create a first record with the transaction ID, and then you generate the query, or you can do a lot of things. Questions?
You mentioned adding an online mode to PG Upgrade. How do you see that actually operating?
You need to have pgdump create a replication slots, and to be able to get that. Actually, you need many parts. You need first the decoder able to generate row queries, which is what I have here, which may be largely smarter than what I have. You need also the receiver part. The receiver server is, in my case, what I have run inside. Like I have a background worker running in a second server that gets a replication connection to the first node and applies the changes like that on the fly. And so you need three pieces: the receiver on the second node, the decoder on the first node, and also a way to get easily a consistent dump for your whole system, which would be in this case pgdump. The problem is that you need to create one slot per database that you want to dump. So when you do a pgdump all, and if you have many databases, you may finish creating a lot of things. And then you create one replication slot and one background worker that fetches the changes for each database. Then the tricky part is to be sure that all the changes have been applied for all the replication slots. And once you are sure that you have that, you have a little bit of downtime just for the switchover. You do the confirmation, you shut down the stuff, and then you can switch over to the new node. Like, it's not really online. You still have a little bit of downtime just to perform the switch to the new node. And if you're able to make the confirmation that each slot changes have been consumed in this case. Like, I'm not sure if it's something that's really doable inside core because it would request a couple of additional modules, perhaps smarter than what I did here. But that would basically be the picture. You could do perhaps something else like using PG receive logical, but yeah, you need things to be applied on live, so you need something inside a second server and a decoder in the first server in this case. So I think that's a long way through that. What we need first is PG dump being able to get a consistent dump for a given replication slot. And I think that the way to go through that is to have kind of PG dump dash create dash slot with a slot name. You create the slot on that and you take a dump from that. Yeah?
Does the decoder get called when a receiver asks for a payload, or does it get called as the events?
When the receiver calls for it. So when you call for a receiver, what happens is that you create a decoding context. You mark the slot as active, so as long as your changes are being computed using the SQL interface or even the replication connection, the slot is marked as active, and then you shape your changes just at this point. You don't call them on the fly. And of course, changes are only available once the transaction holding those changes has been committed. Any questions?
What was the answer to the earlier question about what happens if you've got a transaction that generates, many megabytes of all activity before the commit?
The pre-processing on the decoding side is going to take some time because I think it begins to emit changes only once the transaction has been committed and only once the whole processing has been done. Like I tested that actually. I ran some large generate series using millions of rows and I could see that I let my transaction running and then I tried to request the changes from the replication slots and those things were not available as long as the transaction has not been committed and also as long as the event itself was not over when you decode a single transaction change.
So does that cause any kind of heavy RAM usage or anything?
That's a good question. Like I didn't do any measurements, but the answer would be yes.
So the changes, that's what Kevin's thinking. So the changes are really being accumulated in RAM in the logical decoder on the server until the commit. Is that right?
Yes, I think so. Like we don't spill anything to like it's a tuple store, I think. When you request those changes, I think they are put inside. Like when you decode them from WAL, they are put inside the tuple store itself. But once you generate them inside that, they are put inside a set of string info things. And like I checked that. I'm not sure actually. But yeah, I'm pretty sure that you got that inside on RAM, but perhaps then you split that to disk at some certain point because of course your RAM cannot support that.
Well, anything that's being stored in a tuple store will spill to disk.
Yeah. When once work mem is full, if I recall.
Oh, they're in a tuple store on the back end. There's a running session that's accumulating everything, and that's where it's going. I guess.
Yeah, like I could check. Like I didn't have a look much at the low-level coding in this case, and I didn't do much statistic cases. But I think like it's easy to check that. When you write the plugin change, I can check it in 5 minutes if you want. But after, I don't recall exactly where they store it. It may be something like a tuple store, I imagine.